Hello, dear listeners. Welcome to Semaphore Uncut, a podcast for developers about building great products. In this new episode, Darko, the podcast host, welcomes Adam Wulf, one of the developers behind the whiteboard application Muse. Adam tells us about the journey of Muse to evolve from a single-user app into a real-time team collaboration platform. I hope you enjoy this new episode. Now let's dive in.
Hello, we have with us Adam Wulf. Adam, thank you so much for joining us.
Yeah, thanks so much for having me, Darko.
Yeah, please just go ahead and introduce yourself.
Yeah, well, I've been developer for coming up on 20 years, so a fair bit of time in the industry. Started out on the web development side, lots of JavaScript, lots of front-end development. So right out of college, started a small company, co-founded that and sold that. Since then, have just been jumping from tiny, interesting company to different tiny, interesting company, whether my own or somebody else's. And so it's been quite a rush. So for the past 2.5 years, I've been at Muse Software, where we're making brainstorming, collaboration, whiteboarding, thinking application for that kind of messy thinking work that you do in the middle of the project before you know quite what you're doing. So it's a great spot to pull all of your thoughts down for that. And so that's been a really fun project.
At Semaphore, we're all about helping startups and growing businesses achieve their goals. We're introducing the Startup and Scale-Up plans, which come with a per-seat fee, ensuring that we continue providing the additional value that our users expect. These plans come packed with several new features that were previously only available on our Enterprise plan, such as new machines with faster CPUs and double the RAM and disk space, self-hosted agents for easy auto-scaling and complete control, metrics and insights for improved build performance over time, streamlined releases with powerful deployment controls, and much more. Head over to semaphorecI.com/pricing for more information, and happy building.
For the listeners that might not be familiar with Muse yet, on the high level, it's like an app which focuses on iPad and macOS as platforms. And as you described, it is great for collaborating on ideas. Can you give us a bit more in-depth?
It starts out as just a white canvas. And so it's a kind of a classic whiteboard experience when you first open it up. And then you can drop in images, PDFs, links, kind of various content. What really sets Muse apart is that it's not just a single whiteboard. You can actually put in small cards that represent other whiteboards. And so then you can pinch and you can bring in cards that represent smaller whiteboards. So then you can pinch in and you end up getting a nested whiteboard experience. And so there's your top level root board that has all of your content, all of your ideas, but then you can zoom into the Project A board. And then the Project A board might have various links and content related to that project. It lets you organize your thoughts spatially, and it lets you organize your content spatially.
And for the folks that are using the app, how would you describe maybe the segments from which people are coming? You mentioned, product and project management and so on. So what are some of the interesting use cases that you've seen?
It's a lot of small teams or folks that are on small teams. Designers will use it, product designers or project managers, or anyone who's not just thinking about what do the pixels look like, but what does the user experience look like? What does the pathway and the strategy for the product look like? And so for a small team, maybe the guy right at the top or the lady right at the top who's leading the company and has all of her ideas out there, she's using it for company strategy. But one of the folks who's doing the product development and customer interviews is using it for collecting customer feedback and helping to decide where a particular feature might go, not just the product might go. Yeah, anything from strategy to user experience to product design to any of those sorts of things are really perfect fits for Muse. One
of the key things that is, if I understood correctly, everything is real time. So all the folks that are part of the workspace see everything in real time, what other people are doing. Is that correct?
Yeah, that's exactly right. And that's our newest effort is we're working on Muse for Teams. And so Muse started out in its infant form as everything is on one device and that's it. So it's one person, one device. Good luck.
Single player.
Single player. So then over the past year and a half, we've been working on multi-device, but single player. And so then it syncs from your iPad to your Mac to your phone. So all of your devices are seeing your content. And then our newest effort is Teams. And so there's a handful of teams that we've been working with that are using our our alpha version. It is going to be a team, real-time, kind of digital office space for a metaphor where you can just kind of walk in, see what people are working on. You have all of your content there, and you can easily link out to the rest of the company as well. And I know there's also lots of companies that use tools like Notion or Miro or Slack or any of those. And so we're looking at integrations as well. So that way there's easy ways to have content inside of Muse, connect to content outside of Muse for teams.
I assume when it started in, as I call it, single player mode, the backend where you were storing all the data was, quite different when there's, multiple people, everything in real time. Can you talk about those challenges? And
It was a very difficult transition. So the original application that was on iPad was using core data. So all of that was stored on device and there was no synchronization. So what we needed to do is we needed to, migrate the data to the new sync database format, which is going to be just different, right? A lot of the data will have one-to-one corresponding structure, but some of it not quite. And so we needed to work out the kinks of data could look like this in the old world, but it needed to look like that in the new world. But the really difficult thing is we wanted, obviously, a seamless upgrade experience. And so all of our code in the entire application had never been written to think, what if we swap out the database layer? So everything was tied very tightly to core data. And the transition from that to 100% custom database backend, sync database backend, was very difficult. When you need to refactor such an enormous part of your application, you can either rip everything apart, put all of the engine parts in your garage, and then slowly start to put the engine back together and hope that you have the engine at the end of the day. But until then, you have a giant mess. Or you can make a series of lots of very tiny changes. And you just slowly, tiny step by tiny step, walk from your current world into the new world. And so that's what we did for this, is we slowly walked from the old world into the new world. We had to build a number of protocols, which is interfaces in the Java world, and start using those in our application instead of using concrete classes. And so then all of the core data slowly became one particular implementation of the protocols in our application. And then we can slowly start implementing a new version of those protocols in the sync database layer. And then slowly moving from, now the ink type, instead of using core data, ink is stored in the sync database, even though everything else is stored in core data. And now images are stored in the sync database instead of stored in core data. And so we slowly move over one type by one type over into the new database. In general, that very slow and steady process is what let us migrate successfully, because otherwise it was such a complicated and difficult transition. I think we would have drowned in the complexity. Inevitably, there's nuance in every application. Finding a way to slowly migrate lets us be very purposeful about also solving all of those little bitty edge cases along the way. That was a big piece. And then unit testing, of course, is also another really big piece. Like I said, the entire database structure, database system is brand new. And so there's a lot of risk of just bugs in the new system. Heavily testing all of that new sync layer was extremely important to make sure that the user's data was safe after migration, that behavior was safe, that expectations from the database layer were being met. But then, of course, there were also the types of problems that we solve in a synchronized data world are slightly different than the problems we solve in the core data world. In the core data world, if you delete content, you can just delete it and it's physically gone from the database. In the sync world, it's a lot harder to do that because I can delete something from my iPad that has synchronized to my Mac, that on my Mac I had moved somewhere else. And so then when those two pieces of content synchronize, that needs to resolve to something correct, right? And we can argue about what correct means, but we need to at least have a definition of what correct is. So it becomes a lot harder to delete data permanently from a sync database. There's a number of ways to do it, but we have to be very careful about when that happens. That was another really big technical challenge of making sure that old pathways that used to physically delete items now cannot necessarily do that. So we need to make sure that those old pathways have new behavior so that way they don't delete that content, but will eventually, but not during that code path, right? It was a lot of discussions about defining that correctness. Like we talked about, what happens when I do this and then they synchronize? What happens when all of these various edge cases that synchronization world has that a single player mode does not have? So that was a very big piece that to some extent is answered by the structure of CRDTs, of that conflict-free replicated data type, right? How that database just mathematically functions. Some of that is forced on us, but there's a lot of decisions that we could make that influenced how we migrated from core data into this new sync world to keep all of the users' data safe and to keep our code from ballooning in complexity during that transition.
You just mentioned that, CRDTs are one of the key concepts that you relied on. For our listeners that are not familiar, can you give us, a very high-level overview of CRDTs and how you decided to rely on that?
It can sound a bit magical to say that you're going to synchronize two devices and not have any conflicts. I'll explain kind of at a high level how our database works. And a lot of it relies on the concept of a clock, and that clock needs to be synchronized between multiple devices. The easiest CRDT would be to use a wall clock to say, all right, whoever changed something most recently, you win, too bad, right? But if my Mac was configured a day ahead and I make an edit, then all of a sudden my iPad can't make any edits until that day passes and it can finally catch up to the wall clock. So instead we use what's called a hybrid logical clock. What that does is that gives us one clock that we can think of as a wall clock, but is magically synchronized between all devices. So all devices agree on what that clock value is. And now we can say whoever edited something most recently wins. And that's what we do. But the other important piece is to make sure that when a device overwrites another device, we don't want all of the overwritten device changes lost. And so if I edit something on my iPad while I'm on the airplane, I edit something on the Mac, and then I synchronize, I don't want the end result to be either my Mac wins or my iPad wins, and that's it. And I lose all the changes from the other one. And so the last thing that we do is we have very small attribute value pairs. Last write wins registers is what we call them. They're atomic changes. Those atomic changes are both very, very small. And so when they compete and get overwritten, you're overwriting the very smallest piece of data that is meaningful. And that way, if two devices are editing the same object from the user's perspective, they're very probably changing different attributes of that object. Maybe one of them is changing a text label and the other one's changing a position, and then a teammate you're working with is changing the color. All of those can get merged in and no one's overwriting each other because the attributes that are changing are granular.
Microservices architecture is all the rage these days. But do you know what it really means and how to implement it to empower your teams to make the best decision for the problem at hand? On the Semaphore blog, you can learn about microservices and how to take advantage of features like test reports, monorepo, and Docker support to build, test, and deploy your microservice application at scale. Head over to semaphoreCI.com/blog for more information. And happy reading!
Are there any scalability issues that you have seen so far, or just to make the experience very fluent when a lot of people are editing a board and so on?
The network protocol has also been a very interesting problem to solve. The way that we designed it is everything is an attribute value pair. It's very tiny pieces of change. What we do is we collect a large number of those changes up that are all kind of affecting the same object. And then we wrap those up into what we call a pack. And then that pack gets sent up to the server as just an opaque box of data. And that opaque box of data has a label attached to it that says, hey, this is part of scope A. And a scope is just an identifier of stuff that lives in the same box, right? So for our purposes, a scope is a board, a whiteboard, or a scope is a PDF document, or a scope is an image. And then everything related to that board or that PDF is inside of that scope. So then from the server's perspective, the server knows who users are. The server knows which devices are connected for a user. And the server knows what scopes a user has access to, has permission to edit and permission to change. But the server doesn't actually know what's in that scope. So it's just moving opaque boxes of data around and doesn't really care about application level logic. And so that separation of application logic and application data entirely from the server that needs to synchronize that data between devices has made this entire sync experience so much more stable and so much easier to develop because we can iterate very quickly on the device inside of the app, features, new data structures, new things, new items. And all of that is still using what is essentially the exact same server from a year and a half ago. Like the server is almost entirely unchanged because it can just move opaque data around and it just doesn't care what Muse is. And that protocol could be used for any application. It doesn't matter. It's not Muse specific. And so it has made managing scale on the server much easier problem to handle and can be completely disassociated from the problems of the Muse application.
One of the amazing things that I kind of enjoyed reading about Blender is that they had like forward, backward compatible file format. So with a 4-year-old Blender, you could load a file that was created today.
Yeah, absolutely. And we can't guarantee that a user's devices are all running the same version. And so maybe they updated their Mac more recently than their iPad, and their iPad just kind of sits on their couch running an old version. And so that thought of kind of data versioning has also been top of mind for us. And there's a couple different ways that we do it. At the core application layer, like I said, everything is very, very small attribute value pairs. One of those attribute value pairs is type code. And so every object in the application, whether it's a board or a PDF or anything else, has a type that says, I am a board, I am a PDF, I am a, fill in the blank. And if the application doesn't know what that type is, doesn't know what that type code is, or if for some reason that type code is missing, then the logic on the iOS application, whether it's an iPad or Mac, just ignores that object. It can load all of the new data. Any new data that synchronizes will show up, but only for the data types that it recognizes. Then the other important thing was being able to iterate on the server and kind of the sync mechanisms as well, especially as we kind of broaden what permissions look like. So it used to be multi-device, single player, but we're starting to move into this multiplayer space where I could share something with you or my team all shares content together. And so we have version numbers for the network protocol. Protobuf is what we use over a WebSocket. And so those protobuf messages are versioned. The WebSocket URL that we connect to is versioned. And then the application schema, the kind of attribute value pairs that we care about, or that any particular version of the application cares about, is also versioned. If for some reason a device is on version 2 and it starts receiving version 3 data, it's going to look at that and say, I don't have the protobuf definitions to understand what this version 3 is. So I'm just going to put it over here on the shelf and just kind of not worry about it for now. And so it's still going to get all of the version 2 messages. It's still going to emit version 2 messages, and it's going to play very nicely in a version 2 world. And then whenever that device eventually does upgrade to version 3, it'll look at the shelf and say, oh, look, yeah, a bunch of version 3 stuff. Okay, let me go get that. Pops into my brain another thought is the other thing that we've done that has been very important for us in debugging. When there has been a bug or strange behavior, we put identifiers on everything. Every request has an identifier. Every object has an identifier. What that has helped us do is say, oh, here's a problem. For some reason, this isn't working right. And then we can map a particular request from device A. That request goes to the server. The server sends down that pack to the next device. It unpacks it and makes sure it's read. And so we can trace the full history of any one of those atomic changes.
You guys are essentially building a very complex distributed system, although someone could almost insult you by saying you're making an desktop app or
We want the magic to be right up front for the user, but then all of those IDs and bookkeeping and all of that, just mess of engineering is designed to take the magic out of the system for the engineers. So that way we can easily trace exactly what happened and understand exactly where the bug is and fix it faster than...
You also have many open source projects. Can you maybe just name some of them and give us, some just high-level overview, ones that you maybe have extracted from the Muse or, generally from your previous work?
The first one is performance Bezier. There's a number of operations on Bezier paths that require a full traversal of the path. And so if I have a path with 100 elements, then if I wanted to get the very first point out of that path with Apple's default API, it says, okay, great, hold on. Let me iterate all 100 of these elements, and then I'll tell you what the first point is. And so what Performance Bezier does is it adds in a lot of caching into that default data structure. And so just by linking in that framework, you get a lot of caching that turns O of N operations into O of 1 operations. The second one is clipping Bezier. And what that does is helps you do binary operations on a list of paths. And so if I have a lot of ink strokes and I want to know where those ink strokes overlap, then this will help you clip one path to the dimensions of some other path. And it helps you find intersection points between paths and do all kinds of those operations that are not provided by Apple out of the box. And then kind of the latest one I've been working on is called Pony Express. And that is a notification library. So what Pony Express does is it implements a notification center protocol, very similar to what's there by default in iOS, but adds type safety for Swift. So that way what you're sending and what you're listening to are guaranteed to be the type that you're sending and listening to. And you have a lot more kind of compiler safety built in to help you make changes, or you're not going to trip over yourself quite as often as you would with the built-in implementation.
For people that want to, learn more about you, Muse, your open source work, if you can give us, some pointers where people can find more about you.
Yeah, so you can find more about Muse at museapp.com, museapp.com. You can find out more about me and my open source work at my name, adamwulf.me. Those are the two websites. You can look more into what's the Prison Entrepreneurship Program. So I'm also very involved in that, and that's pep.org. And I write about that some on my blog as well. You can find more about my volunteer work there. But it's a pretty fascinating program that teaches felons in the last few years that they're incarcerated about entrepreneurship and gives them a lot of life skills and entrepreneurship skills and business skills. So that way, when they are released, they have a much better chance at reintegrating with society than they would otherwise.
Adam, thank you so much.
Yeah, thanks so much.
What a great conversation. We hope you enjoyed it and learned something new. Make sure to subscribe to Semaphore Uncut on your podcast player of choice so that you don't miss our new episodes. And stay tuned,